Hello, I'm going to try out TCR. TCR stands for Test Commit Revert. There's an article by Kent Beck. I'll post the link in the in the comments explaining it more. But basically, the idea is that if the test pass, you commit, but if they fail, you revert. And this is done automatically. There's another article by Thomas Denifel, and he suggests a few variations. So what I implemented is this one, the body, which is all the time looking, building and committing or reverting depending on whether the test passed or not. I did it slightly different because it to me doesn't make sense to build it all the time if there were no changes in the files. So what I do is to monitor for changes in the files. So this is what I'm using. So I notify wait to check for changes in source. And what I'm going to try to do is this problem from Let Code, where you have an array of integers and an integer k, and we want to find out the number of continuous subarrays whose sum equals to k. So there are a few different solutions. So my idea is to start with the most intuitive one, the brute force, and build on top of that to see how TCR allows me to do the changes. So let's get started. I'm going to be running TCR here. And so let's return something. I usually use IntelliJ, but IntelliJ doesn't auto-revert the changes. It presents a menu, and that was annoying. So since this is very simple, I'm just using a Sublime text editor. So cool, let's create a test. So we are going to differentiate. I'll use the one from the example, which was 111 with k equals 2, and the output should be 2. So the answer is going to be s.subarray sum array, and answer needs to be 2. Actually, let's put 0 now because I put return 0 here, and the build was successful. So you can see that it committed the change, right? So if I change, for example, this one to 2, then the test should fail. It fails and it reverts it back to 0. So actually what I need to do is how am I going to change both at the same time? This is a problem. Okay, let's remove the assert equals. I can save this one. I can save this one now. So this is something that I need to be thinking around how to avoid. The problem was that if I saved one of the files first, then it wouldn't fail. It will fail, right? So now that I can comment it out. Okay. So it took a little bit of handling. I don't know if there's a better way. Now let's do the trivial implementation, which is just brute force, look all the possibilities. So let's do a shortcut for this because we'll need it a few times, and we're going to iterate. Then we'll have another one, the inner one, and we'll start on I because if we do it inclusive, we can have something that is just one element. And now we need to adapt the values between A and J. We cannot use K, let's call it Z. We'll make it inclusive, as I said, and we'll do sum plus equals nums of Z. And then if the sum equals K, we're going to increment the counter, and this counter, okay, we can save, and this code is not doing much actually, because we are just returning 2. But let's try, for example, what if I did this, that is going to go out of bounds. Nothing happened. I don't know why. I was expecting an out of bound error. Okay, whatever. Let's try to see if this actually works. By replacing it here, seems that it worked. Let's add another test. For example, let's add a 0. If we add a 0, we have 1, 2, and 3, because we can include the 0. And if we add an additional 1, we'll have 4. So this should be 4. Let's see. Yes, it worked. I find this to be a little bit slow. Maybe there's another way of making it compile faster, but this is a fast computer and the code is very small. It's just a couple of seconds, but since I'm compiling all the time, it feels a little bit slow. Okay, this seems to have worked. Let's see, for example, if we introduce a bug here, it should automatically revert it. Great. Cool, so now we have a solution. Now I want to improve the solution, and this is order n cube, because we have 3 fourths, one inside the other one. And actually what we can do is keep track of the partial sum. So for example, when we have 1, 1, 1, 1, 1, our partial sums will be, if we start before 0, 1, 2, 3, right? So if we have the partial sum, we can just compute the sum, for example, between this one and this one by subtracting 3 minus 1 is 2. Actually, if I want to, for example, compute the sum of everything, is this element minus this one. So let's work with this. We'll do a partial sum. Let's call it PS. And we'll have one more element. And the first element is going to be 0. And now let's populate this. So the partial sum of the following element is the previous plus the number in the position I. We can save. Hopefully that this doesn't break anything. Great. And now what I want to do is replace that line and compute the sum in a more efficient way, which is sum equals PS the J minus PS the I. But actually, for what I show you here, this aligns more like this, so it's J plus 1. Let's try it out. Yeah, it worked. Can delete the things. If I want to make sure that it worked, let's say that I change something here. Hopefully it will revert it. See, this couple of seconds feel like a lot when I'm doing these small things, but I'm not sure if I will be doing these things in a real scenario. Okay, so we were able to, another thing that I like is being able to, for example, do this trivial change like this, right? And I save and I can see that it's working. And okay, this solution can be improved even further, because what's going on is that we actually know what we are looking for. What I mean is that, for example, if the partial sum is 5 and we want to find on case 2, then if we find a previous partial sum that was 3, then we can add it up. So let's try incorporating this here. That solution should be even faster, should be order n. So let's use a hash map, and this is the count. I can do like this, right? And then we have one element with the value of 0. Let's save. Oops, something was wrong. It seems that it's not compiling. I cannot find a symbol. I need to import java.util star. And now hash map. What's going on? Integer. I'm used to IntelliJ, which helps you more than this. I think it's put, not set. Right? Yes. Build successful. Well, we didn't do much, just initialize a hash map. And now actually what we want to do is we can populate it here. So we can set, we're going to put for the element, for this element, we are going to put the previous value, or 0 plus 1. So with this we are populating it, and what we need to do is we need to iterate again and check if we already had it. So actually we can even do it in the same for loop. And one thing that is happening to me is that I feel tempted to delete this code, but if I delete it, it will fail and it will appear again. So this is, I'm not sure if it's good or bad. It helped me keep the code that is working here. But at the same time, here I'm mixing the new and old code. So let's see how it works when I want to clean this code up. So if I have a partial sum, now I can have a target that is going to be this partial sum minus k, right? Yes, let's say that the partial sum is 5 and k is 2. Then we need to find a target of 3. And what we can do simply is, let's use another counter, right? Because if I use the same, I wish I could use dot, but if I use it and I save, it's going to break it. So let's use dot 2. And what we need to do is find the number of target. Let's do it or default. Great. And so basically we add the number of the target that we have. I think this could work. Let's replace by dot 2. Oh, that's right, it worked. I'm surprised. Okay, let's see if we had done something wrong here. For example, let's put getter default 1. Build successful. I don't know, let's try something else. Oh, of course, I'm returning Todd. Let's imagine that I got it wrong and put the plus initially, and I do Todd 2. Then it should revert me back to Todd. Great. But with minus, that is the right solution. It works, and let's go back to Todd 2. Great, it works. Let's clean up the code. So for example, I can delete this, save. Great. So I think I like more TCR when it's about refactoring or fixing the code where you can save and then you're confident that you're not screwing up anything. For creating new code, it felt to me that I was working around TCR. I don't know, maybe I'm doing something wrong or there's a better way, but it felt a little bit like it wasn't my way. Now for this, I like it more because I can do the changes, and then when I save, I make sure that I didn't screw anything like I just did. Something is wrong. It didn't revert it. Because it doesn't compile. Okay, when it doesn't compile in this version of TCR, it doesn't revert the code. Cool, now it succeeded. Cool, the code is looking nice. Well, the only thing is that let's do a last refactor. We actually don't need to keep the last values because we just care about the last one. So again, this is a small refactoring. Let's call PS2, and this will be PS2. Let's save. Great, it worked. Now we can actually clean this up. Yeah, this can be plus equal. I can make PS. Great. This seems to be working. Cool, it worked. Out of curiosity, let's try to see if it actually works in let code. It compiles. Yeah, it worked. So yeah, TCR is an interesting experience, and definitely it's a bit different the way you need to think about things. It keeps you on your toes because you know that if you screw up something, then your code will be reverted. Other times when I tried for the first time, I kept using Ctrl-Z in my editor to fix stuff. So for example, let's say that I think like, oh, this is useless, and I saved, then it appears back, right? But imagine that I was doing something reasonable. I do undo, and then I do whatever change I wanted to do. I like being able to save and come back to the state. Actually not, because this doesn't compile, but if it compiles, it comes back to the previous state. Okay, that was it for now. I'll think a little bit more, maybe try another example. Thanks, Kent. Thanks, Thomas. Goodbye.